Now let's move to the third point, construct validity. Okay, so let's discuss on construct validity. I hope liability is clear. It is measured by Cronbach alpha, and how we measure the Cronbach alpha, we have seen that. Now the question is that what is the meaning of validity? Why validity is required? Uh, so I'm explaining the basic concept of validity. Suppose you want to check your blood pressure. You go to the doctor and ask him to do check your blood pressure. The doctor say that your blood pressure is 160. You may not believe that, right? So you think that the doctor is telling me lie. The doctor machine may be wrong. So you have to confirm it that I do not believe that my blood pressure is 160. So you go to another doctor. The another doctor also say that the blood pressure is 160. Then you start believing that yeah, my blood pressure is 160. So that is a kind of validation. Validation of what? Validation of the measurement. Validation of the measurement, right? So if but that is the case of machine. Now the question is that if you ask some question to a person, and it is possible that that person may speak lie or may give you the wrong answers, right? So it is a natural tendency to validate. For example, suppose you are taking the interview of a person and you are asking that what were your grades in let's say 12th class. So suppose the candidate say that I secured 99% marks in my 12th class. So you must try to validate it by looking at the documents. So that is a kind of validation. Similarly, whenever we measure the responses through questionnaire. Now in this case, the questionnaire is known as instrument. What is the questionnaire? Questionnaire is known as data collecting instrument. So the questionnaire is defined as a instrument for data collection. And in the questionnaire, you are having the statements. In the questionnaire, you have many statements. Those statements are known as scale, right? So there are two different things. One is the instrument, and second is the scale. Whatever items, whatever construct you are measuring in the questionnaire, that portion is called scale. So we use two terms very frequently, that what scale we are using and how we are collecting the data by which instrument. So questionnaire is the instrument, and the statement and the construct in the questionnaire is called scale. Now we are going to measure the validity of this scale. So what is the construct validity? Construct validity is the method by which we are examining the validity of the scale. This line is very important. So in other words, I can say whatever construct you are measuring, whatever statement you are having in the questionnaire, we want to validate that construct and the items. So that scale in the literature is known as measurement scale. Measurement scale, because we are using these statement to measure something. For example, if I want to measure the job satisfaction, I will put the items of the job satisfaction, and these items is known as measurement scale. I want to know whether it is a valid scale or not. So it is 100% compulsory that you have to prove whatever scale I used in the questionnaire is a valid scale. So that validity is known as construct validity. There are different kind of validity. In research, you may came across with content validity, phase validity, nomological validity, concurrent validity, predictive validity. So there are different type of validity. But here we are talking about the validity of the scale. What is the scale? Scale is the items and the construct mentioning in the questionnaire. And questionnaire is the instrument. So this validity is known as construct validity. So tell me one thing. If anybody asks you, whatever scale you are using is a valid scale, so you have to prove it. How you have to prove it? By applying this technique is known as confirmatory factor analysis. Confirmatory factor analysis is a method where you are proving that your scale is a valid scale. So there are two types of validity in construct validity. One is convergent validity, and second is discriminant validity. There are two types of validity in this: convergent validity and discriminant validity. So first of all, we have to understand that what is the meaning of convergent and discriminant validity. And second thing, we should know how to measure it. So first of all, I'm going to explain what is convergent and discriminant validity. So this slide explains you the definition of convergent and discriminant validity. So convergent validity is representing that whether the items you are using to measure some construct are highly correlated or not. So let me represent by a diagram so that you can understand with more clarity. Suppose we are measuring, this is, let's say, attitude. Attitude is measured by, let's say, 5 items. So we want to know that this is attitude 1 first item, attitude 2 second item, attitude 3 third item, attitude 4, attitude 5. So convergent validity say that all these items are significantly correlated. So all these items means statements are significantly correlated. How much? Greater than 0.7. So the average correlation between these items must be, this is not should be, must be greater than 0.7. So this is the first condition. And this average correlation is reflecting by numbers which is coming here, 0.8, 0.7, 0.7, 0.7, 0.6, like this. So these numbers are, because if they are highly correlated, all these numbers should be greater than 0.7. So these numbers are known as construct loadings. So first condition of convergent validity is that all the construct loading should be greater than 0.7. Second condition is this average correlation. I'm telling you the average correlation is greater than 0.7. This is measured by composite liability. Composite liability is representing the average correlation between the items. So I called it composite liability should be greater than, must be greater than 0.7. The first condition is that the construct loading should be greater than 0.7. Composite liability should be greater than 0.7. So both are the conditions are almost same. We have one more condition of convergent validity. The condition is called, we are having another measure called average variance extracted. Average variance extracted indirectly is the square of this, is the square of 0.7. So we have a round off value that is 0.5. So that should be greater than 0.5. So our AVE should be greater than 0.5. So we are having only 3 conditions for convergent validity. Number 1, construct loading should be greater than 0.7. Composite reliability should be greater than 0.7. And average variance extracted should be greater than 0.7. And one thing I also want to share with you, that what is the methodology of finding out this composite reliability and average variance extracted. Suppose there is a, this is attitude. We are having 5 items measuring the attitude, and this is 0.71, 0.72, 0.78, 0.81, 0.67, like this. Okay. Now the composite reliability is actually calculated by summation of beta I upon summation of beta I square plus E square. So this is the formula for what is beta I. All these values are beta I. So what I'm going to prove here, composite reliability is also the function of construct loadings. Similarly, if we calculate the average variance extracted, this is summation of beta I square upon summation of beta I square plus E square. So both CR and AVE we can calculate from the values of construct loadings. So that's why which value is the root of all these things, right? So what is the root? Root is nothing, it is a beta. So the convergent validity is calculated, all values of convergent validity is calculated from the beta. What is beta? Construct loading. And what is construct loading? Construct loading is representing the correlation between item and the construct. And the range of beta is 0 to 1. 0 to 1. And it should be greater than 0.7 for the best of the result. So that's it. You should know about the convergent validity. So let's move to the slide so that we can see all these things written in the slide. So convergent validity extent to which the construct have correlation with the items. This is definition. There are three conditions of convergent validity. Construct loading should be greater than 0.7. Composite reliability should be greater than 0.7. Average variance extracted should be greater than 0.5. So now I'm going to show you that how we can check these three results. So for that, we have to move to the PLS. And in PLS, now I'm going to show you how we can get all the three measures. And believe me, you cannot write a paper by skipping this value. You have to represent these three values: construct loading, composite reliability, AV. And how to report all these values? For that, I send you a paper today. Okay, now let me show you that how we can measure. So this is the model. Again, we are going to calculate. Again, we are going to consistent PLS algorithm, start calculation, and all the values you can see here. So this is the composite reliability. This is average variance extracted. And the condition we need to check is that composite reliability should be greater than 0.7 and this value should be greater than 0.5. So two conditions we have to check from this table. So you can see that all composite reliabilities are more than 0.7. All AVE values are greater than 0.5. And after this, we can go to a value called outer loading. So let me show you this. So we have this outer loadings. So outer loadings means construct loadings. So let me click on it. In outer loadings, in this outer loadings, most of the values, in more than 90% of the values should be greater than 0.7. One or two value is, if less than 0.5, 0.7, not a problem. Minimum requirement is 0.5. Like in this first case, this is career growth. We have 7 items. 6 items are having the value more than 0.7. Only one item is having value less than 0.7. Now the question is that should I drop this statement or I should keep this statement? The answer is that because this value is approaching 0.7, so we have no problem. But if my CR is value less, then I may drop this value also. Suppose I have the composite reliability value 0.69, it means we are not satisfying the condition. So you can remove the values, some of these statements which are having construct loading less than 0.7. But here we don't have the requirement of do that because our conditions of CR and AV is fulfilled. So no need to drop it. And I think we are having most of the conditions fulfilled. Only there is only one value which is not fulfilling the condition. So we can leave it. So all the three conditions of convergent validity are fulfilled. So I have no problem in that. So I'm writing all the three conditions. The first condition which we need to check, the outer loading should be more than 0.7. Composite reliability should be greater than 0.7 and AVE should be greater than 0.5. So all the conditions are satisfied, not a problem. We are happy. And now we can go to discriminant validity, which is the next type of validity. So first of all, we should understand what is the meaning of discriminant validity and how to check it. Discriminant validity is based on a concept called cross loadings. So first of all, let me explain what is the cross loading. Suppose I have three constructs. This is X, this is Y, and this is Z. So there are three constructs. And X is measured by three items, Y is also measured by three items, Z is also measured by three items. So this is X1, X2, and X3. This is Y1, Y2, and Y3, Z1, Z2, and Z3. So we assume that all the three constructs are independent. Now, if I put all the three variables here, suppose let I say I put here X1, X2, and X3. So this is called cross loadings. So whatever loading I am getting here, the value, these values are known as cross loadings because you are adding item of X into the item of Y. Right. So the point is that these cross loadings should be very low. If these cross loadings are higher, it indicates that the items are representing Y. Like for example, this is marketing department, this is finance department. If marketing faculty teaches finance, you are having a confusion that are they marketing faculty or finance faculty. So we assume that marketing faculty cannot teach finance. So these loadings should be very poor, very low. So this concept is the root of discriminant validity. Right. Now the question is that we don't do that. We are not attaching the values. So we are measuring something else. So what else? Let me explain. Okay. So what we are doing, we are trying to find out the correlation between, let me find out the correlation between X items and Y items, X items, Z items, Y items, Z items. So we want to find out the correlation between the items of the different constructs. Right. And this correlation, the correlation between X and Y, the correlation between Y and Z, the correlation between X and Z should be less than AVE. So correlation should be less than square root of AVE. This condition is the first condition for discriminant validity. Right? Because if you remember what is AVE, AVE means how much the item of X explain the variance of X. It should be more than the correlation of X and Y, the correlation of X and Z. So this concept is called Fornell-Larker criteria. This formula is known as Fornell-Larker criteria. Let me write another way. So what Fornell-Larker criteria says? The Fornell-Larker criteria says, the spelling is Fornell-Larker criteria. Fornell-Larker criteria says that the square root of AVE of each construct should be greater than the correlation of that construct with any other construct. Right. So this is the condition which you can see in almost every paper based on SAM. In 100% of the papers, you can see this criteria, Fornell-Larker criteria. And this is criteria number 1. The second criteria is called the HTMT ratio. HTMT ratio. So what is HTMT ratio? Just try to understand. Suppose this is X1, X2, X3. This is Y1, Y2, Y3, and Z1, Z2, Z3. So these are the items. Similarly, we can write here X1, X2, X3, Y1, Y2, Y3, Z1, Z2, Z3. The correlation between X1 and X1 is 1, X2 and X2 is 1, X3 and X3 is 1. So Y1 and Y1 is 1. So this diagonal is always 1. This is the correlation between X1 and X2. Basically, this part and this part and this part. So this is the correlation between X and X. This is the correlation between Y and Y. This is the correlation between Z and Z. So these correlations are known as mono trait. Mono means single, mono trait. And the other part is called hetero trait. Hetero means correlation with its correlation within called mono, correlation between called hetero. And the ratio of mono trait and hetero trait is known as HT-MT ratio. So HT-MT ratio is the formula is correlation between X and correlation between Y. Let me write again. So HT-MT. HT is coming upside, MT is coming this. So this is the correlation between X and Y, and this is correlation between X and correlation between Y. So this ratio is called HT-MT ratio. So let me show you in this slide. So we have two measures of this is construct validity, formula is written here, all explained. Discriminant validity we measured with two concepts. So the first concept is, you can see here, this is Fornell-Larker criteria, and this is called HT-MT ratio, and this is the formula for HT-MT ratio. Now the simple thing which you remember, because when you see the software, the output is coming in this format. In this format. So in this format, the first value and bold value, the first values and the bold values, these values are the square root of AVE, and all other values are basically R. So what is the conclusion? Conclusion is that the bold value should be greater than other values in the column. This 0.790 should be greater than 679, 344, 414, 581, 458. So the first value should be greater than all other values in the column. And in this condition should be fulfilled in all columns. 0.739 should be greater than all these four values. 0.802 should be greater than all these values. 0.771 should be greater than all other values, like this. So this simple condition is known as Fornell-Larker criteria. Okay, I will show you in the PLS also. And HT-MT ratio, because the software give you also the HT-MT ratio, the HT-MT ratio should be less than 0.8. So this is the condition mentioned in the book. So now I am showing you how to measure the discriminant validity. So these are the tables which I show in separate. Fornell-Larker criteria table coming like this. The first value is under root of AV, and if any construct is formative, you just write formative. In formative, we don't need to check discriminant validity, like this. And if there is some single item construct, right, you can write like that. Similarly, the HT-MT ratio is, this is called mono, this is called hetero. So mono trait, hetero trait. Overall conditions are this. So we have to show these two ratios. A square root of AV should be greater than correlation Fornell-Larker criteria, and we have to show HT-MT ratio. These two things we have to prove that discriminant validity is there in the scale. Now I am showing you how to check discriminant validity.